Next, we talk about simplifying square roots using perfect squares. We've done this a couple of times, but let's zoom in better with this video. Simplifying square roots using perfect squares. Simplifying square roots means rewriting a radical so that no perfect square other than one remains inside a radical. And then we remember perfect squares are a perfect square is a number that can be written as an integer multiplied by itself, right? So common perfect squares will be things like 1, and the square root is 1, 4, square root is 2. That means that 1 raised by 2 is 1, 2 raised by 2 is 4. 9, the square root of is 3 because 3 raised by 2 is 9. Then we have it all the way down to 144, whose square root is 12 because 12 squared is 144. Then we have the product rule of radicals. This has been implied in many things we've done previously. So talking about the product rules of radicals, we say that to simplify square roots, we use the fact that square root of a multiplied by b is equal to square root of a times square root of b. So, and the steps here, find the largest perfect square factor, then rewrite the number as a product, separate the radicals, and simplify. For instance, in example 1, we have this that we have this you have factor. Okay, I guess I want to make it as big as as can be. So factor 12 down. So you have 12 is 1 times 12, then which is then 2 times 6, which is then 3 times 4. So these are possibilities of uh, the expressions of 12. But we see here that 4 is a perfect square. So we can say root 12 is root 4 times 3. And because of the product rule, product rule of radicals now, so because 4 now, I mean 12 can be written as 4 times 3, then square root of 12 is square root of 4 times 3. And we can break it apart to say this is root 4 multiplied by root 3. And square root of 4 is 2 multiplied by root 3. So we have a mixed surd, which is 2 root 3. And that is how we can express square root of 12. And that is the final answer. We have the same thing for root 18. For root 18, see, you factor 8, 18 into 2 times 9. That's straightforward. 9 is a perfect square already. So root 18 is square root of 9 times 2. So that's square root of 9 times square root of 2. Square root of 9 is 3, and then root 2. And that's the answer for root 18. Now, how about um, talking about extracting largest square factor? Of course, that's what we've been doing before now. Always choose the largest square factor. Example, simplify root 72. So factor 72. 72 can be written as 8 times 9. Of course, there are other perfect squares you can get from here. You can get like okay, always choose the largest perfect square factor, right? So factor 72. 72 is 8 times 9. So 9 is a perfect square. So you have root 72. That's root 9 times 8. And that's it. Give 3 root 8. But 8 is still not it's not there yet because it's not in this simplest radical form. So you go again, you see that 8 can be written as 8 times 2. I mean 4 times 2. So you have 3 root 4 times 2, and that means square root of 4 is 2. So 3 times 2, 6 root 2, and you have 6 root 2 right here. Now, just like if you want to follow what we've been doing before, we talked about root 72. All right. So if you have root 72, you know, it can easily be written as root 36 times 2, and that's root 36 times root 2. Root 36 is 6, and then root 2. So we can go on like that. Though, I mean, out of 72, for 72, right, you can have something like 4 times, I think, 18. Yeah. You can have, you can even have 9 times 8. You can have you can have 36 times 2. So you go for the biggest one and then you just go straight like that. Okay. So we have all of that too. Then we talk about prime factorization method. This is the most important method if you ask me, because sometimes some numbers are so big, you can't know upfront. You may not be able to figure out upfront which is the perfect square, the biggest square, right? So, but prime factorization will come to your rescue in that case. So this method always works. It works for whatever. So simplify root 50, for instance. So prime factorization simply means breaking down 50 into 2 times 5 times 5. But how do you even know? Let's assume you don't, you're seeing the number for the first time. So all you just need to do is, we are still going to talk about uh, the factor tree or so. So this is 50. Clearly, it ends with 0, so it means 2 can divide it. So 2 goes in 5 2 times, remainder 1. 2 goes in 10 5 times. This is 25. 5 can surely divide anything that ends in 5. 5 in 25 is 5, then 5 again. 5 in 5 is 1. So at the end of the day, you see that 50 is equal to 2 times 5 times 5. And it helps to be able to write this as 2 times 5 raised to power 2 for easy uh, for easy application of the radical. So you have root 50 equals root 5 squared times 2. Root 5 squared is 5 in short. So 5 root 2 is the answer for this now. So prime factorization is the big deal at the end of the day. So you have root 180 and it can be written as 2 squared times 3 squared times 5. How? Just go step by step. Talk about root 180. So here now we have 180. So 180 ends in 2. Start with the smallest prime. We are talking about prime factorization. So start the smallest prime number is 2. 1 is not a prime number, by the way. So 2 in 180, that's 90. 2 in 90, that's 45. So in 45, 3 can go. 3 in 45 is 15. Then 3 can still go in 15. 3 in 15 is 5. And then 5 can go in 5. So we have 1. So then it means that 180 is equal to 2 times 2, 2 times 2 times 3 times 3 times 5. Then it also helps to write it in index form. This is 2 in 2 places, 3 in 2 places. That's 2 squared times 3 squared times 5. And to now take the square root of 180 now. So root 180 simply means taking square roots of 2 squared times 3 squared times 5. So that means you have square root of 2 squared times square root of 3 squared times square root of 5. So square root of 2 squared just makes pick only one. Pick 1, 2, and square root of 3 squared, pick only 1, 3, and then root 5. So 2 times 3 is 6, and then you have root 5 like that. So that's the square roots of 180 using prime factorization. So prime factorization is your go-to approach anytime, any day to solve, to handle sorts like that. So a square root is in simplest radical form when no perfect square factors remain inside and no fractions remain under the radical. So no radicals appear in the denominator at the end of the day, right? So to simplify 48 now, we know 48 is simply if you do the long thing, 48, okay, I've always been doing that. Let me just go for it. So 48 now, so straightforward. So 2 goes in 48 24 times, 2 goes in 24 12 times, 2 goes in 12 6 times, 2 goes in 6 3 times, then 3 goes in 3 1 time, and that's it. So you have 48 equals 2 times 2 times 2 times 2 times 3. So that's like 2 raised power 2 times 2 raised power 2 times 3. So it's better to group it in this form so that the square root can be easily taken care of. So square root of 48 now is equal to square root of 2 squared times 2 squared times 3, which is square root of 2 squared times square root of 2 squared times square root of 3. So that means square root of 2 squared, that's 2. Square root of 2 squared, another 2 multiplied by 3. So you have 4 root 3 as the square root of 48 in that manner. Okay, that's 4 root 3. Then for 200, of course, 200 is simply 100. Okay, I feel I should just still do that. I know it's very straight to the point, right? I just feel like I should not leave it to chance. So 200 now, of course, 2 goes there 100 times. 2 in 100, that's 50. 2 in 50, that's 25. Then 5, 5, that's 5. Then 5 again, that's 1. So that 200 now is equal to 2 times 2 times 2 times 5 times 5. Okay, so that square root of 200, of course, index form is always cool. So you have 2 raised power 2 times 2 times 5 raised power 2. So you then have square root of 2 squared times 2 times 5 squared. Okay, and that is equal to square root of 2 squared times square root of 2 times square root of 5 squared. So that is square root of 2 squared is 2. You have your root 2 there. And square root of 5 squared, that's 5. So 2 times 5, that's 10. And then you have the root 2 here. So that's 10 root 2. So, what if you want to simplify? You can also simplify with variables, right? Um, Example, the square root of x squared is always absolute value of x, or usually it can be written as x in algebra classes, right? So, for example, another example, you want to simplify 18x squared. So, 18 is 9 times 2, then x squared is x squared. So, square root of 9 is 3, square root of x squared is x, then root 2. So, square root of 18x squared is square root of 3x root 2. That's 3x root 2 actually. Then for this other one, you have square root of 75x cube. So 75 is 25 times 3. So that's 25 times 3 times x cubed. Then this one now you can break it apart. You have square root of 25. In x cubed, you have x squared. Then you have 3 left and x left. So square root of 25 is 5. Square root of x squared is x. So square root of 75x cubed is the same thing as 5x root 3x. And that is what you have there when you simplify that. So that takes us to the practice problems. So the first 10 questions, simplify completely. Write answers in simplest radical form. I think I'm just going to take only one of these since I've done ample examples of this particular one. Which one should I take now? Everything is simple actually. Okay, let me just take 10. That's square root of 45. That's straight to the point. Square root of 45. So we need the square root of 45. Okay, so do um, prime factorization. So 45, 3 goes in 45 15 times. Then 3 goes in 15 5 times, and 5 goes in 5 1 time, so that 45 is equal to 3 times 3 times 5. And that means we have 3 squared times 5. So square root of 45 then is equal to square root of 3 squared times 5. That is square root of 3 squared times square root of 5. Okay, and that is 3 root 5. And that's it. So we look at 11 to 20 and see what else we can do there. All right. So for 11 to 20, I think I'm going to I'll take question 16 and question 20. 16 is square root of 80 L6 M8. Okay. Square root of 80 L6 M8. Square root of 80 L6 M8. Okay, so we know already that okay, maybe we can do 80 by the side. So this is 80. So 2 in 80 is 40, 2 in 40 is 20, 2 in 20 is 10, 2 in 10 is 5, and 5 in 5 is 1. So that means we have this now to be square root of 80. So this is 2 raised to power 2 times 2 raised to power 2, that is 16, right? Times 5. And then L raised to power 6 is L raised to power 6 is L. Okay, well, we can just leave it as L raised to power 6 times M raised to power 8. Um, because if I want to expand it, that'll be a lot, but it's okay. So we just then have so here now we have square root of 2 squared times square root of 2 squared times square root of 5 times square root of L6 times square root of M8. Okay, that's square root of 2 squared is 2, square root of 2 squared another 2. We have root 5 here. Square root of L6 is L3. Just take half of that, just like we take half of 2 raised power 1. So you have that's L6, and square root half of power 8, that's M4. Okay, so we then have 4 L cube M4 root 5. Okay, 4 L cube M4 root 5, like that. Because if you square this, that'll be 3 times 2, 6. If you square this, that's 4 times 2, 8. So all this now, root 5. So let me take the last question. That's question 20, like I promised. So 147 W cube. Okay, I feel that cropping may be necessary here. So I don't have to go back and forth. Um, okay, let me just crop this. So copy, and then I come here and paste. So we paste now. Yeah. So we need to do this. So this is the same thing as root 147, right? 147 W cube X squared Y cube Z squared. Square root is covering everything. And of course, for 147, right, we can break it down. 147, 1 plus 4, 5, 5 plus 7, 12. So if you add up all I know 2 cannot divide it. That's why I'm trying 3. So if 1 plus 4 is 5, 5 plus 7 is 12. If you add up the digits and this what you get can be divisible by 3. It means 3 can divide that number. So it means 3 can divide 147. So 3 in 14 is 4. That's 3 times 4, 12. Remember that 2, 3 in 27 is 9. Okay, and from here now, 7 can easily divide this. 7 in 49 is 7, and 7 in 7 is 1. So that tells us that we have uh, this to be square root of 7 squared times 3 times W cubed now is W squared times W times, okay, I guess I want to bring this down. Okay, this is square root of 7 squared times 3 times W squared times W, because there's W cubed. X squared remains what it is. Then Y cubed, that's Y squared times Y squared times Y, right, times Z squared, like that. So so that the other will not be too elaborate, I'll just have square root of 7 squared is 7. Square root of W squared is W, you know. So take note, we have 3 left, we have W left. Square root of X squared is X. Square root of Y squared is Y. We have this Y left here. And then square root of Z squared is Z. And then everything into square root of the 3 that was left there, that 3, then W that was left, that W, and this Y. So that means that square root of 147 W cubed X squared Y cubed Z squared is 7W XYZ square root of 3 WY. So, and with that, we come to the end of this interesting video talking about simplifying square roots using perfect squares. Okay, so let me know how helpful this is for you. Don't forget to try your hands on the other problems, and so you can be sure you really understand what's going on here. So let me know how helpful this is for you. If there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, thank you very much for doing that. If you haven't subscribed, go ahead, subscribe, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also become a member of the channel by clicking on join, and that gives you some special privileges like getting to see some videos first or getting to see some videos only you. And then you can also make requests for PDF copies of my notes that I use for to teach some of these topics, like that. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.